With this quick demonstration, I want to give you an example of adding design intent and intelligence to a 3D model. In this case, it's an imported IGES file, perhaps coming from a supplier or a vendor. So I'm loading an IGES file right now. Bring that in. You can see the part. This part might be used in this particular scenario in different configurations, so we may want to add some design intent to it. Here you can see the IGES file comes in as an assembly. I'm just going to put it at the top level and delete that assembly. So we're working with just the part. There's no intelligence in this. There's no feature information. It's just geometry. So to add design intent, we're going to use Creo Elements Direct, the parametric capabilities. And I just created a set, a relation set that's assigned to this part. It's owned by this part. And now the first step is I'm going to define a set of faces that will be considered fixed. These faces will not be allowed to move in the edits of this part. So matching the design intent that I have in mind for this particular part. So those are the faces that are grouped as fixed and cannot move. And the next set of faces that I'm going to group together will be considered faces that can move, but they must move together as a group. We call that rigid in this case. And so all of these faces will be considered rigid or grouped together. And I need to also include these bosses in that. So we'll use feature recognition to find those bosses as a feature inside the IGES file here. And include those in the rigid relationship. So there we have the rigid faces, and then it's just a matter of adding a few additional relationships. I want to make sure that this set of rigid faces that will move will always stay coincident with that whole, and then we'll add an angle relationship so we can use to change the angle of this part, and that may be required in an assembly configuration. And we may want to adjust the length of this particular area of the part as well, depending on again, the assembly configuration. So this is kind of a family apart type of a situation. We've just added the fixed, the rigid, the coincident, angle, and distance. Certainly not fully constrained, but it's everything that I need to capture the intent that I need in this particular part. And again, this is an IGES file. So here you can see we can also turn on labels, so you can see the relationships in labels on the model or in the structure browser, or you can use this this table here to interact with your relationships. You can see the 90, that's the angle of this part. Let's just give it a try and change that to 120, and sure enough, everything updates. Again, this is an IGES file that we just added a little bit of intelligence to. Let's set it back to 90. Now before we go on and build different configurations of this part, let's create a quick drawing. So we'll go to annotation here and create just a single view drawing. In this case, I'll just select the front view. And in this particular case, for this particular dimension, considering what might change on this part, I'm going to add some geometry to help in the definition of the dimensions. We'll just add a quick angular dimension, clean off that label here. These dimensions are just slaves. They're not driving dimensions. In this case, it's just annotation I'm adding to this. So the 2D drawing in this case is just a slave to the intelligent 3D model. Here's a dimension I want to make sure stays parallel with that side face. We'll do that again. Maybe just put another dimension here and lock it parallel to that side face as well. And so there's a really rough drawing. We'll stick with that. While I'm here, notice that I can actually change the parameters in this table to 120. The model is now up to date. And then we can simply update the drawing. So there you can see the changes in that. Let's go back to 3D. You can see that the model is, in fact, modified to that 120 degree change. And so now for maybe for another part that represents a little different configuration in the assembly, let's create a new part. And in this case, I'm going to reposition it. Normally wouldn't do this, but I want to do this to show you to highlight kind of the differences here with the two models. They both are identical right now. They both have individual relation sets assigned to them that we can manipulate independently. So let's go back to our first model, and we'll change that one to 90 degrees and maybe make that leg a little longer. Maybe go to 60 on that or something like that. And then we'll activate the relation set that's on the new part that we just created, and we'll adjust the parameters that are in that particular part. And so you can see you can duplicate this part over and over and define a unique set of parameters for each one of them. So let's go back to our drawing now, and it'll of course update that particular part. And then we want to add our second part into the drawing. We can add it as a new drawing, as a new sheet, or just as a new view in this drawing, and that's all I'll do right now is just create a new view on this drawing. And there you can see that that view is up to date and reflects the particular configuration of the model in its current state. Let's change it back to 90 and update the drawing. You'll see that. And we could even go to back to 120 here and update that drawing. In this case, we'll need to just move the view over a little bit, make sure there's spacing there on the view. But again, you can put that view on a new drawing, on a new sheet, or in this particular drawing as well. So I hope that makes sense. We just added some intelligent design intent to an IGES file to get it to comply to my design intent with no need to understand how the model was created, where it was created from. There's no need for modeling standards. There's no need to confuse modeling intent with design intent. I hope that makes sense, and thanks for watching.